matter to me. I think I have a test here. You said 18? The Gauss-Jordan? Okay, so let's do it again. I think I thought we did it, but maybe not. Maybe I'm wrong. So x plus y plus z equals -3. X minus y minus z equals -3. X minus y plus z equals -11. Okay, so this is a 3 by 3 linear equations in 3 variables. And we want to solve using Gauss-Jordan. First, we have to make sure that the system is presented in the correct order. It turns out that it is. It's exactly what we wanted. We could already start by writing the augmented matrix. And we cannot deviate, as we mentioned before, we cannot deviate ever from the sequence of steps. So one more time, 1 at the top, the corresponding zeros, 1 in the middle, the corresponding zeros, 1 at the bottom, and the corresponding zeros. This must be the sequence of steps. Okay, so it happens that we already have that starting point. So obviously in the first step, I have to use row 1. In the second step, I will be using row 2. In the third step, I will be using row 3. So I'm using row 1 because I need to get a 0 here and here. And I'm asking myself, what do I multiply this by to add it here and get 0? And in both cases, the answer is -1 indeed. So -1. So let's do this together. First, I have to copy the row that will not change. The row that does not change is the one that I'm using. In the first step, I will be copying row 1. In the second step, I will be copying row 2. And in the last step, I will be copying row 3. So 1 times -1 plus 1 is 0. 1 times -1 minus 1 is -2. 1 times -1 minus 1 is also -2. And -3 times -1 minus 3 will be 0. Do we need to repeat this step? Is this okay? This is basically the elimination step. We're multiplying one equation by a number and adding it to another equation. Okay, now for the last one. 1 times -1 plus 1 is 0. 1 times -1 minus 1 is -2. 1 times -1 plus 1 will be 0. And -3 times -1 will be +3. But -11 +3 will be -8. So the first column is done. Where do I look next? Well, the answer is must be in the middle. The next step after the first column is done must be in the middle of the next column and the second column. And this must be -1. This must be 1. Because this one will help us eliminate this. And this one will help us eliminate this. And there's no problem to make a 1 here. I will divide both sides. I will say the entire row 2 by -2. Dividing everything by -2 will give us a 1 in the middle, in the second column. So then 0, 1, 1, 0. Because I divide -2 by -2, -2 by -2, and 0 by -2. Now, if you want, you can divide here, but there is no point. So 0, -2, 0, -8. So we accomplished the first column and the middle in the second column, and that's what I need to proceed with. So this is the second step, so I have to use row 2. So I will be using row 2 to add it to row 1 and row 2 to add it to row 3. But now I have to identify what does it need? What do I need to multiply a second row by to eliminate the 1 at the top of row 2 and the -2 at the bottom? Yes, For the top, I will have -1, and for the bottom, I will have a 2. Agreed? Very good. Which row do I copy now? Because I know it will not change because I'm using it. Yes. And make sure that the first column does not change because then we are in big trouble. 1 times -1 plus 1 will be 0, and 1 times -1 plus 1 will be 0. 0 times -1 will be 0, minus 3 will be -3. Do we agree with the first row? Yes? Okay. So now, 1 times 2 with minus 2 will be 0. 1 times 2 plus 0 is 2. 0 plus 0 times 2 is 0, minus 8 is -8. So now, what we accomplished, we have the first 2 columns done. My target has to be the bottom of column 3. Because without making a 1 in there, I would not be able to eliminate the zeros above. So I will divide row 3 by 2. And I get 0, 0, 1, -4. In the final step, I have to multiply row 3 only by one number to add it to row 2 because row 1 does not need anything. So what do I need? The only thing that I need to eliminate is this. Nothing else. What do I multiply row 3 by to eliminate this? -1. So finally, I have 1, 0, 0, 0, 1, 0, 0, 0, 1, of course. So let's do this together. 1 minus 1 plus 1 is 0. -4 times -1 is 4 plus 0 is 4. So the solution appears to be this. And I do have to go back and check. But it works. Is this better? Is this better? Yes? Okay. Next question from anything. Forgive me, I think I forgot to turn off my phone. I'm going to do it just now. Yes, next question. Annie, you had something?
12.
Yes.
Topic of test 3 is the log of x plus log of x plus equals
X plus 15
uh-huh.
equals?
2.
Good. So first, this is a log equation, and log equations have restrictions. And the domain for this is what? What do I have to write for this to exist? What can log be applied to? What type of numbers can I apply log to? Log is a function with restriction. It's not defined everywhere. We wish it were, but it's not. So how do I find the domain of this function, log x? What do I have to write? Do we know anything from our back notes or anything? Say it again. Not yet. I want to say the common domain. I need to say the domain of the first function, the domain of the second function, find the common domain, and then condense. I cannot condense and then find the domain. It's not going to be the same. So the domain is always stated on the raw equation. Don't touch it. You have to state the domain first. Exactly with the rational equations, if you remember. Before we move terms around, before we factor the denominators, before we find the least common denominator, we have to state the restrictions. Same thing here. At that time, we were still looking for the common domain. Same thing. Yes?
Specifically?
No, for log x first.
Oh,
What do I have to write? We wrote this at least 10 times so far. I was hoping that by now we know this. Yes, x? Exactly. So the function is not defined at 0. It's not defined at negative numbers. It must have a quantity that is greater than 0. Otherwise, log does not exist. So this is the domain. This is the inequality that will give us a domain for this function. Now I need an inequality that will give us a domain for the second function. Right. But will you be able to remember this more than 1 minute from now?
Yes.
That's my target. My target is not for the next 1 minute. Okay. So this inequality says this. This inequality says this. I need the common domain. If we don't see it, it's okay. We have to graph it, but we have to find the common domain. One of them says 0 to infinity. The other one says negative infinity to 0. So what is the common domain where both exist at the same time?
0.
Excellent. In other words, this guarantees that if I find a solution that is greater than 0, I'll say okay. If I find a solution that is less than 0 or 0, what will I say? Not acceptable. Awesome. Good. So then now let's condense. Now I'm ready to condense. How do I condense the left-hand side? Log, yes, which is common log. What is the base for common log? 10. Very good. Log. Perfect. Very good. Very good. And to be understood that we have this. Perfect. Excellent. Now what do I do? Right, but that's the next step. That's fine. I can do that. I can write it as log x squared plus 15x. Fine. But then I have to change it into an exponential. That's why I asked what is the base of log, because that's where I have to start. Yes. So how do I change this into an exponential equation? Yes. Yes. 10 to the second power equals x. Exactly. Excellent. Once I change it into an exponential, actually it collapses into a quadratic, which is even better. So now I have x squared plus 15x minus 100 equals 0. Because it's quadratic, I have to move everything to one side. Very good. Well done. And then, if you remember, we said if it takes more than 20 seconds, 30 seconds to factor, forget it. Quadratic formula right away. Because the product is negative, we want a positive and a negative. Positive and negative. And their sum is 15. So 100 is 2 times 2 times 5 times 5. 10 times 10. 2 times 2 times 5. So let's say if we can get a positive number and a negative number that will add up to 15. Can we find that? Using all these, group them into two numbers whose difference is 15. If not, it's okay. Let's find the solutions with the quadratic formula.
20 times x minus 5.
Very good. Awesome. So it happens that we have two possibilities, x equals negative 20 and x equals 5. However, we worked hard and we even promised ourselves to remember the domain of the log. And we said that the common domain is, aha. So what do I conclude then? I will say yes, no. Very good. Now, you can say, and I will have to agree with you, and I will agree with you if you say, I don't like this method of finding the common domain. But I promise to go back and check. But you have to go back and check. So I think it's more difficult to go back and check, and you may forget, than state a domain from the beginning. But it's up to you. But you have to use one or the other. Because see, if we hadn't stated a domain, and if we hadn't gone back to check, we would have considered both solutions correct. But negative 20 is not correct. If you plug in the calculator and put in negative 20 here, you'll see what happens. Let's do that. And because we know the graph. So if I put log negative 20, what do you think the calculator will say? Will punch me in the face. Right. Because log, here, remember the graph of log. Look at the graph of log. This is also very important to remember. Any log with a base greater than 1 looks like this. And negative 20 is here. It has nothing to do with the function. The function is not defined to the left of 0 or at 0. It has a vertical asymptote at 0. Very good question. Anything else? I think you said you had more than one, right? Yes, what is it?
1/3 power x minus 2, I think, because I'm just did some notes on it, I'm not sure. Yeah. Is it x minus 2? That's a power in power. Equals 9 power 2x plus 3.
Very good. Okay. Obviously, this is what type of equation? Of course, because the power, yes, has the variable. You don't see the variable anywhere else but at the power level. If it is at the power, it must be exponential. Good. Now the next question I will ask you is, can we present both sides with the same base? Because if we can present both sides with the same base, there is no need to apply log. Now you can say, forget it. It's easier for me to apply log. Fine. You can do that and you will get the same answer. It's up to you. I still believe that it's easier than finding both sides, or if that's the case, presenting both sides with the same base than applying log. Okay, so the right-hand side is very clear. 9 will be presented with what base? Nine. I'm talking about 9. Will be presented with what base? What is the only way I can rewrite 9 in any way, shape, or form? There is only one other way. Oh, you can say, exactly, that's all I meant. Now let's look at the left-hand side. Can we make that 1/3 be something with 3 raised to a power? Because if we can, then three raised to power. So 1/3 is the same with 3 raised to which power? -1. Very good. So yes, the answer is yes. I can present both sides with the same base. So now I copy the base, and what happens with the exponents? Not yet. I'm not there yet. But you're correct. That's our target. I copy the base. What happens with the exponents? You may have been already on the next step.
-1 times x plus 2.
Very good. And the right-hand side, awesome.
4x plus 6.
That's it. So now we say, because the exponential function is 1 to 1, two numbers are equal and they have the same base, what has to happen to their exponents? That's it. I still believe that it's easier to solve a linear equation like this than applying log, but you will get the same answer if we apply log. So I move. So this is negative 5x equals 4. X equals negative 4/5. There is no need to go back and check unless you want to. Why? Because the exponential function is friendly. There are no restrictions on the exponential function. If we got negative 4/5 and we didn't make an error down the road, this must be it. No need to go back and check unless you want to. Good. Next question. Very good questions.
Maybe we could finish that 15.
Yes,
Same test.
did we start it and we did not finish it?
No. I mean, so we're gonna have like a full set of.
Yes, of course. Yes, of course. Which one?
Let's solve the system of nonlinear inequalities for inequalities. And it's 2x minus y less than 6 and x squared plus y squared less than equal to 9.
Very good. So this is a system of nonlinear inequalities, and the only chance we have here is to graph. So we have to start by writing the equation. We are not changing anything, but we need to write the equation because we have to graph it first. So then when x is 0, how much is y? Negative 6, because there is a negative. So 0, negative 6. And the other one, when y is 0, how much is x? Very good. So this is 3, 0. So now I'm going to graph 3, 0 and 0, negative 6. I have to stop and ask myself if I am going to graph it as a solid line or not. Not. Very good. Awesome. So this is just the equation 2x minus y equals 6. I will be using the origin to check, which means I'm checking the region to the left. I'm testing the region to the left by picking 0, 0. 0, 0. Is 0 less than 6? Yes. So I have to shade in all this. All this area except points on the line represent solutions to 2x minus y less than 6. I repeat the process for the other one. But what do I know about x squared plus y squared equals 9? What do we know about this equation? This equation is the equation of a circle. Awesome. Center, please. 0, 0. And the radius, please. Very good. Solid curve or not?
Yes.
Perfect. 1, 2, 3. 1, 2, 3. 1, 2, 3. Good. So I see that the circle divides the entire plane into two regions, the inside and the outside. I check with the origin, 0, 0. 0 less than or equal to 9. So then I shade in. Now, I do have a dilemma here. And here's my dilemma. Is this line really tangent to the circle? Or my graph should have been this way? So I don't know. What I'm going to do is to see whether the line crosses the circle in 1 point or in 2 points. How do I do that? Well, I'm going to solve the equation, the system, 2x minus y equals 6, and x squared plus y squared equals 9, and see if I get one solution or two, or none. Well, I do have at least one solution for sure. It's this point. But if I find another point, then I know it crosses the circle again. So then my initial graph is not 100%. Okay? So let's do that. It's a very good practice. 2x minus y equals 6, and x squared plus y squared equals 9. I know that one of the solutions must be 3, 0. Do we all agree with that?
Yes.
Because 3, 0 are points on both. Right. It's a point on both. Very good. So then from here, let's say I solve for y. So 2x minus 6 equals y. And then I replace it here. So x squared plus 2x minus 6 squared equals 9. So I solved the first equation for y. I got 2x minus 6. And I replaced y in the second equation by 2x minus 6. And I squared it. When we square a binomial, how many terms do we get? Very good. First term squared. Minus 2 times the first times the second. And plus 36 and minus 9 equals 0. First term squared, 2x squared. 2 times 2 is 4. 4 times 6 is 24. And 6 squared is 36. Very good. Let's see what we get now. We better get 3, 0 as one of the solutions for sure. Okay, so then 5x squared minus 24x. And plus, is it 27? Correct? Okay, so let's use the quadratic formula now. Negative b plus or minus b squared minus 4ac, 4 times 5 times 27 over 2a. So I'll grab my calculator and see what we get. Because I think it appears that we'll have two solutions. Plus the square root of 24 squared minus 20 times 27 and divided by 10. Of course, I got 3, as I expected. And now I'm checking, I'm getting the other one with a negative. Yep, 1.8. So x equals 3 and x equals 1.8, which means that now I have to go back and adjust my graph as I expected. So at 1.8, which is here, as expected, this is the circle. It crosses the line in 2 points. So the common is only this, the common territory, not this piece that is outside to the right of the line. So everything inside the circle, everything on the circle, not points on this piece of the line, but everything inside. And not this, because it's outside to the right. That was a very good practice on solving nonlinear systems. Good. Next question. Anything else?
Go over
Number?
16.
From test 3?
Yes.
You said 16? Very good. I have a test here, someone who didn't claim it yet. 16, 14, 15, 16. Yes. I thought we did this last, but that's okay. I'm sorry?
I think we did already.
But if you need me to...
Oh,
No?
for sure.
Okay. Okay.
we
Yes.
had to go over,
Yes, any? Which one?
number 12 on the final review, final sample.
Okay. I don't know if I have another one here, but can you tell me what it is?
Log of X. Wait.
I just got it. I just got it. I just got it.
You're gonna use the D.
So you said number 12.
Oh, yeah.
I just got it. This one?
Yeah, no, never mind.
Okay.
Can we do the number 10 for the same test?
Yes, number 10. Yes, perfect. So here we have x squared. Test 3 or this one?
This one, the final.
Yeah. So x squared plus y squared minus 2x plus 4y minus 9 equals -5. Very good. Okay. So here we're asked whether this is the equation of a circle. And the answer is I have no idea. As long as I can, if I can present it in the form of x minus a number squared plus y minus a number squared equals a number squared, if I can present this like this, then the answer is yes. If I cannot, or if this is 0, or if this is a negative number, or this is minus, or who knows what else, I will say no. It's not a circle. So where is my starting point then? Yeah, this is the least of my concerns. I can do that at any point in time. But yes, you can. I'm not saying it's wrong, but I don't even care about numbers yet. I need to form a perfect square with x. So x squared minus 2x. What does it need? To both sides. Say it again. No. I'm looking, complete the square. -2. -2 divided by 2 is -1. -1 squared is 1. The procedure of completing the square. We're adding 1 to both sides. So then this term and this term and this term is x minus 1 squared. Right? Now we complete the square with y. Y squared plus 4y. What do I need to both sides? Squared. So positive 4 divided by 2 is 2. 2 squared is 4. So I need to add 4 to both sides. So then now this and this and this plus y plus 2 squared. Now these are not taken into account yet. -9, -5, 1, and 4. But 4 plus 1 and minus 5, these go away. And now I move 9 to the other side. And then, therefore, the answer is yes. This is indeed the equation of a circle.
Oh, so we did apply +1 and +4 to the numbers also there.
I cannot add to one side 4 and not add it to the other. I have no choice. I destroy the balance. So if I say to you, I have a pound here and a pound here, if I add 2 pounds here and not here, the balance is no longer valid. So if I choose to add 4 to one side, I must add 4 to the other. There is no other way. So then on the other side, we have 4 plus 1 minus 5, which is 0. And now -9 is the only free term that gets moved to the other side. So the answer is indeed yes. This is the equation of a circle. What would be its center? Careful. It's x minus h. So h is 1. And k is perfect. And the radius is, that's it. So this is indeed the equation of a circle, centered at 1, -2 with a radius of 3. Very good question.
Is there any other way to find the perfect squares without adding 1 and adding 4? Because I do it like in my head, I will do the x squared minus 2x, and then I group y's, and that's why I missed that 5. I would have trouble with that, I should say.
The only way is completing the square. So you have x squared and you have -2x, you know you have to add 1. from the first day of classes, x squared minus 2x plus 1 is x minus 1 squared. 4y squared with plus 4y, you can only add 4. The third term has to be 4 for you to complete the square with y plus 2. It has to have 3 terms. Only 3 terms can form a perfect binomial squared. If I don't have 3 terms, I can never get a binomial squared. Vice versa, when I have a binomial squared, I have 3 terms. I have to, when I square this, I get y squared plus 4y plus 4. But if I put 4 here, I have to put 4 there. So I'm not really sure what was the method when you said if you're doing it in your head. I'm not sure what. I'm not saying it's not possible. I'm just saying I'm not sure what the question is. Because complete the square is complete the square. I don't think of another possibility, but who knows? Yes?
How did you decide to add 4 to both sides? And how did you
So the complete the square method is this. Middle coefficient, -2. Divide the middle coefficient by 2, get -1. Square -1 and get 1. There are 4 steps. The middle coefficient, we divide that in step 2, we divide it by 2. In step 3, we square the answer from step 2. And in step 4, we add that number to both sides.
Oh.
Yeah, this is from the method of completing the square to solve quadratic equations from chapter 2. And I'm sure there is something here. Let me see, maybe not. No, there's no complete the square because that problem contained complete the square already. So let me write these down for you again. I'm hoping that you're going to review what we covered so far to get into before you take the final. So step 1, identify the middle coefficient, which in this case is -2. In step 2, divide it by 2. -2 divided by 2 equals -1. In step 3, square -1 and get 1. Step 4, add 1 to both sides. You need 3 terms to complete a perfect square, a binomial squared. So that's why x squared minus 2x plus 1 will give us the x minus 1 squared. And for y squared plus 4y, 4 divided by 2 is 2. 2 squared is 4. Add 4 to both sides because y squared plus 4y plus 4 is y plus 2, everything squared.